we're going to talk a little bit more about logarithms. We've seen their graph, but we haven't really talked about what they are, at least in notes. So we've talked about it in class, but not in the form of notes. So I'm going to give you some notes on logarithms today, and by the end of these notes, you'll have a better idea of what a logarithm is. Just to review exponents, because exponents and logarithms are closely tied. Say we had the problem x cubed equals 8. How would you solve that? Well, we want to isolate x. Which we could do by taking the cube root of x cubed, which equals x. So we would do that to our left side. We'd have x by itself. Well, what you do to one side, you have to do to the other side. So the 8 over there, we're going to take the cube root of that, and we get 2. So we end up with x equals 2. So what if you had an equation like this? 3 raised to what power equals 81? This is an example of an exponential equation, or in other words, an equation with variables in the exponent. Examples might be 2 raised to what power equals 32, or 25 raised to what power equals 5, or 9 raised to what power equals 1/3. And we're going to learn how to go from exponential notation to logarithmic notation, which helps us solve for the exponent. Helps us figure out what the exponent is when it's unknown. So say you had a problem like 3 raised to the x equals 81. We would put it into logarithmic notation and write log base 3 of 81 is equal to x. So here is the problem in exponential notation, and here it is converted to logarithmic notation. In logarithmic notation, again, it's read as log base 3 of 81 is equal to x. So log notation is always equal to whatever the exponent was in exponential notation. As you can see in exponential notation, x was the exponent. In log notation, it's set equal to x. So log notation is equal to the exponent, and we use it to find out what the exponent is when it's unknown. So the inverse of an exponential equation is called a logarithmic equation. What the logarithmic equation means, so we were asking ourselves 3 to what power is equal to 81? You could guess, or we could learn how to do that, and we'll learn how to do it in a second. But let's just look at, just worry about converting, and then we'll worry about solving these, okay? So try converting these 3 problems from exponential to logarithmic notation, and then you're going to try converting from logarithmic to exponential. So go ahead and try that on your own, okay? Hit pause and try it on your own. Don't just wait for me to put the answers up here. Hit pause and try it on your own. Well, there's the first one. You might have needed a little help. We would read 4 raised to the x equals 64. When we put it in logarithmic notation, this would be read as log base 4 of 64 equals x. So pay close attention to where things are. Look at where the base goes. Okay? In exponential, here's the base. Now in log form, it's in the subscript. Next, the exponential equation was equal to 64. Well, now we put it in this place. And remember, log form is always equal to whatever the exponent was from exponential form. So x was there, now it's here. Now, I'm serious. Try the next 2 and 3. Go for it. There you go. Hopefully your answers match up with that. So now we're going to try converting from logarithmic to exponential notation. All right. Same idea, just pay attention to where things are placed. So I'll do the first one with you guys. Log base 7 of 49 equals 2. So let's put this into exponential form. All right, so, well, we know that our exponent is going to be 2, right? Because log form is always equal to whatever the exponent was. So what would the base be? Well, remember when we read it, log base 7 of 49 equals 2? What number did we say right after we said base? We said 7. So 7 is going to be the base. All right, let's go ahead and put this 2 where it belongs. Right there. This log is always equal to the exponent. So what is this exponential problem going to be equal to? Well, what's left? 49. 7 squared equals 49. And it should make sense. What is 7 squared? It is 49. So we know we did it right. Okay? Let's try number 2 and 3. You guys go ahead and do that on your own. I don't see enough pencils moving. Do them on your own. Come on. And there they are. What I'm going to go ahead and do now is show you how to solve when you have a problem like this, say log base 2 of 16. It might not even say what it's equal to, so we got to know that we're looking for what? Let's put it in exponential notation to make it make a little more sense. So if we put log base 2 of 16 into exponential, we would have 2 raised to the x equals 16. So just remember, log should always be equal to the exponent. In change of base form, here's how you can do it on your calculator. Okay, you got to be careful with parentheses, but this will be very helpful. We're going to do log 16, close the parentheses, divided by log 2, close the parentheses, then you hit enter. That's going to tell you what x equals. You're going to get x equals 4. So let's try the second one. When we see it like this, we don't even have to put it into exponential form. We can just go straight to the calculator and say log. You just have to know which one comes first. So log 144. I say the bigger part comes first. The bigger part goes on top. So log 144 divided by log 12. And that's going to give you your answer. These, we're going to get x equals 2. All right, so keep that in mind. That's called change of base. This you should write on the back of your notes. There's not one already filled out for you, so if you guys can just turn it over to the blank part of your notes, you can copy this stuff down. This is just stuff I thought that you might like to see also. We'll talk about it later, but common logarithms, that's when you don't see a number in the base. So if you saw like problem 1 through 3, you would just read log 4, log 23, log 1/2. A common log is when you have log base 10, okay? So log base 10 of 4, for instance, it's the same thing as log 4. All right. Then we also have off to the side natural logs. Let's make a little note here in the corner. Natural log is, say you had log base e. That's equal to ln. Okay. So you guys can evaluate log 4, log 23, and log 1/2 on your calculator, and write down the decimals that you get to 4 decimal places. But so on these, you're simply just going to hit the log button, which is on the very left side of your calculator next to the number 7. So you just hit that log button and then type in the number that appears, like log 4, close the parentheses and hit enter. For log 4, you should get 0.6021. Log 23, you should get 1.3617. And log 1/2, you should get negative 0.3010. So how can common logarithms be used to solve exponential equations? Remember we talked about change of base? Well, those examples, we didn't see anything really that quirky. You know, we were getting nice integers as our answer. But say you had 3 raised to what power equals 11. That's the original problem in the exponential form. So if we converted it to log form, we'd have log base 3 of 11 equals x. Well, on our calculator, we would then say, all right, log 11 divided by log 3. We would hit enter. Get about 2.1827. All right, number 2, it's back to a nicer problem. You have 2 raised to the x equals 32. Well, let's put it in log form. Log base 2 of 32 equals x. And then you're going to say log 32 divided by log 2. Make sure you close the parentheses. And what we're going to do is find out what x equals. So what are you waiting for? What'd you get? So hopefully you got 5. If you think about it, 2 raised to the 5th power equals 32. So for that first one right here, x was equal to 2.1827. And then for the next one, x was equal to 5. All right, so hopefully you have a better understanding of logarithms and exponential functions and how they're related. And now you guys can try the practice problems on your own.